Everyone says Saturn's rings are ancient, formed alongside Saturn itself 4.5 billion years ago. But here's the odd part. Up close, these rings look almost brand new. What exactly erased the years? After billions of years in space, Saturn's icy rings should be tinted gray, polluted by dust, debris, and micrometeoroids. Instead, they're as clean and fresh as a mountain glacier. What's missing from this picture? Space is filthy. Micrometeoroids constantly pepper Saturn's rings, smudging every surface. The more grime we measure, the older the rings should be. But when that ice stays pure, it's as if their clock keeps getting reset. Even worse for the rings, Voyager and Cassini caught something stranger. Charged ice actually rains down into Saturn's atmosphere, a slow-motion drain, steadily siphoning the rings away. Are we just seeing them in their final glow? But maybe the rings cheat the clock. What if they're just so massive, even layers of dirt barely register on the shimmering ice? Bright rings might just be heavy rings pretending to be young. Or is that wishful thinking? We tried every trick: radar, light curves, even star occultations. The ring's mass just dodged us, hidden behind confusion and guesswork. It was a perfect mystery, until one last spacecraft took the risk scientists always wanted. So in 2017, Cassini threaded the needle, flying again and again inside the rings. Every pass let Saturn's gravity warble Cassini's radio tone back on Earth. Those tiny frequency shifts pointed straight to the answer. With every wobble in Cassini's signal, we watched the gravity of Saturn wrestling with the pull from the rings themselves. The key? Each Hertz shift directly revealed how much those icy bands really weigh. Meanwhile, Saturn's atmosphere glows infrared as ring rain pours down. H3+ emissions hint that this icy downpour could erase the rings entirely within just 100 to 300 million years. Could this be their final act? Two clocks started to merge. Cassini's measurements of incoming crime stacked perfectly with ring brightness. Both pointed at a surprisingly short window. But the question hung in the air. Did the mass agree? Some models said a shattered moon made the rings. Others argued we're seeing leftovers from Saturn's birth. But with either story, the true mass was the judge. Which origin gets to survive Cassini's findings? With Cassini's final data, scientists peeled Saturn's gravity field apart, strip away the planet's inner tug, subtract the zone's roaring winds, and the remaining signal isolates the rings themselves. All that was left was to weigh them. Cassini's final numbers landed in 2019. Saturn's rings are shuftingly light, about half the mass of Little Mimas, not nearly enough heft to hide a billion years of grime. Their youth jumps straight out of the data. All the evidence locks together: low mass, clean ice, and high grime rates. The rings hadn't had time to get dirty. That means Saturn's ring system likely sprang to life within the last 100 million years. Could random collisions endlessly clean the ice? Models say no, at least not for low-mass rings. Ring particles can shuffle grime, but they can't erase it forever. Renewal alone can't explain such blinding brightness. So what did happen? The simplest answer points to a major breakup. A moon or passing comet ripped apart in Saturn's grip, spreading brilliant debris into the rings we see sparkle above our telescopes today. There's a catch. At current rates, these rings are already vanishing. In another 100 to 300 million years, they'll be gone. We're seeing Saturn at a rare moment, caught between two ringless eternities. Saturn's rings aren't timeless. Cassini's gravity dives prove it. They're recent, dazzling, and soon to fade. Most people have never heard this explained. Now you have. Subscribe so you don't miss the next one.